Hi children, today we are going to discuss mechanical properties of solids and units in measurements, the two previous NEET and JEE questions from these two chapters. So let's start the discussion. See the first question, children. Given below are two statements. One is labeled as assertion and the other is labeled as reason. Assertion: product of pressure and time has the same dimensions as that of coefficient of viscosity, and coefficient of viscosity is equal to force per velocity gradient is the reason. And this is the question given in JEE Main 2022. So let us first of all, in the assertion they given that pressure into time. Okay, see, pressure into time. Pressure is nothing but force per unit area into time. Force Newton and area unit is meter square and time second. So Newton second per meter square, the product of pressure into time. And in the assertion they are saying that it is same as that of the coefficient of viscosity. So here viscous force is given by children 6 pi eta r v. So coefficient of viscosity eta will be F divided by 6 pi r into v. So for force unit is Newton, and for r value it is meter, and for v velocity meter per second. So again it will be Newton per meter square per second. So we can write this one as Newton per meter square into second. So here if you observe carefully, the product of pressure and time and the unit for coefficient of viscosity is both same. But here the reason, if you observe carefully, it is given as force per velocity gradient. Okay, so coefficient of viscosity is the product of force divided by r into v, where v is the drift velocity here. So the formula that is given in the reason is not correct. So we can go with option C, that is assertion is true but reason is false. Okay, next question. See that next question. A student in the laboratory measures thickness of a wire using a screw gauge. The readings are 1.22 millimeter, 1.23, 1.19 and 1.20 given. The percentage error is x divided by 121%. Now what is the value of x? So here the values are given. So let us first of all find out the mean value. Okay, that is 1.22 plus 1.23 plus 1.19 plus 1.20 divided by 4. So you will get it as 1.21 millimeters. So after finding out the mean value, so next you should find out the absolute errors in each and every measurement. Okay, that is delta x1 first of all, that is modulus of, so 1.22 minus 1.21. okay, as you are taking the modulus, even though if you are getting the difference a value as a negative, the total final value will be positive only. So it is 0.01. So if you continue like this, no, so you will get the values for absolute errors, that is delta x1, delta x2, delta x3 and so on, and the final value will be 0.06 divided by 4, and it will be again 0.015. This like this, children, delta x1, delta x2, delta x3, all the values you should find. So the corresponding values will be 0.02, 0.02, and even delta x4 value we will get it as 0.01. Right, again if you take delta x, that is mean of all these values, delta x mean, so delta x1 plus delta x2 plus and so on divided by 4, so you will get the value as 0.015. Now relative error, how to find out that relative error, children? So that is delta x divided by mean value, delta x mean divided by x mean. So what you will get, 0.015 divided by, and x mean is 1.21 into 100. So if you simplify this, so you will be getting it as 150. Okay, so 0.015 divided by 1.21 into 100. So that means here you will be getting the value like 150 divided by 121. So in the question they given it as x divided by 121, no? So in the place of x we are having 150. So see the next question. In LCR circuit, that means inductor, a capacitor and a resistor. L is nothing but self-inductance, C is capacitance, and R is the resistance respectively. So which of the following does not have the dimensions of time? So here, children, so if you try to substitute the values of inductance, capacitance and resistance, dimensions, that is dimensions, and if you try to multiply R into C and L by R and root LC and L by C. Okay, so you will be getting the value for the dimensions of the time in each and every three options, but you will not be getting the dimensions of time in this L divided by C. Okay, so that is the reason why here we are going to choose the option D. L by C does not have the dimensions of time. Okay, next question. As we already discussed this in the class, so I am not repeating the same thing again. Okay, next one. The distance of sun from the earth is 1.5 into 10 power 11 meter, and its angular diameter is 2000 seconds. When observed from the earth, the diameter of the sun will be. So see, we are observing this from the earth at two different positions. So now the diameter of this one will be d and the distance is r, and here angular diameter is given theta, so it is given as 2000 seconds. So we should convert that one into radian, and here we know the formula that theta is nothing but arc by radius. So we are using this formula here, theta, 2000 given, no? So 2000 divided by 60 into 60 into pi by 180. So that is equal to what is arc value? D. What is the radius? It is given as 1.5 into 10 power 11. So now if you simplify, you will get the value for D. Okay, the diameter of the sun as, so 1.45 into 10 power 9. Just right. Next question. The SI unit of a physical quantity is Pascal second. The dimensional formula of this quantity will be Pascal second. So Pascal second. It is similar to that of the first question, children. Pascal means it is nothing but a pressure, and a second time. So pressure is nothing but force per area into time. Okay, so M L T power minus 2 divided by L square into T. So if you simplify, you will get it as M L power minus 1 T power minus 1. So option 1. See the next question. A silver wire has mass 0.6 into plus or minus 0.06, and similarly radius and length also given. The maximum percentage error in the measurement of its density they are asking. So density is nothing but mass by volume, so we can write this one as mass as area into length. Again area we can write it as pi r square into L. So now delta rho by rho is equal to delta m by m plus 2 into delta r by r plus delta L by L. So by substituting the values, okay, here we can get the percentage error in the density. Okay, that is delta m value is how much? So 0.006 divided by 0.6 plus 2 into delta r value 0.005 divided by 0.5 plus delta L 0.04 divided by 4. So if we simplify, finally we are going to get this one as 4%. Okay, that is option A. Next, in a vernier calipers, each centimeter on the main scale is divided into 20 parts. So that means 20 main scale divisions will be is equal to what? 1 centimeter. No? So now if 10th vernier scale division coincides with the 9th, so 10 VSD is equal to 9 MSD. So from this first line we can write main scale division as 1 by 20 centimeter, children. See, from this second line, 1 vernier scale division we can calculate it as 9 by 10 main scale divisions. What 1 main scale division is nothing but 1 by 20 centimeter, no? So VSD is equal to 9 by 10 into 1 by 20 centimeters we can write. So now here they are asking us to calculate vernier constant, which is nothing but 1 MSD minus 1 VSD. So that is equal to 1 MSD 1 by 20, 1 VSD, it is 9 by 200. So if you simplify, so you will be getting this one as 5 into 10 power minus 2 millimeters. Right? Next question. So the elongation of the wire on the surface of the earth is 10 power minus 4 meter. The same wire of same dimensions is elongated by 6 into 10 power minus 5 meter on another planet. So here elongation is directly proportional to G. So elongation produced in earth divided by elongation produced in a planet will be is equal to G value on earth divided by G value on the planet. Okay, so now elongation of the wire on the surface of the earth they given how much? So 10 power minus 4. Elongation, that same wire of dimensions are elongated by 6 into 10 power minus 5 meter on another planet. Acceleration due to gravity on the surface of the earth 10. So what is GP? Acceleration due to gravity on that planet. So if you simplify, you will get the acceleration due to gravity on the planet as 6. Okay, next. The elastic behavior of the material for linear stress and the linear strain is shown in the figure. The energy density for a linear strain of 5 into 10 power minus 4 is energy density they are asking, children. So energy density formula is what? Energy density, it is nothing but half into stress into strain. Okay, so here we know that Young's modulus Y is equal to stress divided by strain. So from this, stress can be written as Y into strain. So if you substitute here in the place of stress, energy density can be written as Y into strain square into Y, 1 by 2 into strain square into Y. So strain they given as 5 into 10 power minus 4 whole square, and Young's modulus we should get it from the graph. So to find out the Young's modulus, okay, they are asking us to take the help of this graph. Young's modulus Y is nothing but stress by strain, no? That is stress strain graph slope will give you Young's modulus. But here if you observe carefully, it is a strain stress graph, that is reciprocal we should take. Okay, so slope, it is stress 20. So for the 20 it is 20 divided by, we'll get it as 1 into 10 power minus 10. So that is 20 into 10 power 10 Young's modulus. So 20 into 10 power 10. So if you simplify this, okay, you will be getting the value as 25 for energy density. Now see the next question. The expression for the dimensionless quantity P is given by, so here it is a dimensionless quantity, and P is given by alpha by beta is equal to log E of KT by beta x, where alpha and beta are constants. X is the distance and K is a Boltzmann's constant and T is the temperature. Then the dimensions of alpha will be. So now, as they are saying that it is a dimensionless constant, so that log of that KT by beta x, so will be is equal to 1. So from this beta can be written as, so KT by x. Okay, and here K is a Boltzmann's constant and x is distance and T is temperature. Okay children, so beta is equal to I will write it as KT value as ml square T power minus 2 divided by L. So children, why I am writing that KT value as ml square theta minus T power minus 2 means, actually this is the dimensions for energy. So energy dimensions, how I got that one means, here for energy distribution in kinetic theory of gases we will be getting the energy distribution, kinetic energy distribution in different directions as 1 by 2 kBT. So here the dimensions of energy, it is similar to that of the product of K and T. Here Kb is a Boltzmann's constant, but in this question they given that K as a Boltzmann's constant. So dimensions will be similar to that of energy for this KT. So I written that one. So beta value, it is ml T power minus 2, ml T power minus 2. So but here if you observe the question carefully, so here P is a dimensionless quantity. If it is dimensionless, then in this equation alpha by beta should have the same dimensions, then only the resulting physical quantity will be having no dimensions, that is alpha is equal to beta, and both the physical quantities will be having the same dimensions, ml T power minus 2. Okay, so this is question number 10.